All right, well, thanks everyone for coming to my talk on migrating beyond Java 8. My name is Dalia, and I am the IBM WebSphere development lead. My team deals with developers that are trying to migrate between different scenarios. So they're on-premise environments, they're going to the cloud, they're wanting tooling for that, or they're going from different Java EE versions, or they're going from WebSphere Traditional to Liberty. And one of the many scenarios that we deal with is they're upgrading their Java ECE. So we had tooling for when they were going from Java 6 to 7, 7 to 8, and then now we were kind of debating how are we going to do this new release cadence, what are we going to do for that, and we read a lot of doc, we did a lot of research, and I wanted to kind of compile it all into one presentation so I can share with you what I found out and what we ended up doing in our tooling so that hopefully you guys can take advantage of that. So before I get started, I usually like to know where people are at right now. So does anyone have Java applications that are already running on Java 13 or 12? No, no one? All right, Java 11. Cool, few people. All right, 9 or 10? 8? All right, awesome. 7 or 6? You're just playing with your hair or you're raising your hand? I know it's hard to admit that, but I do have users that are on Java 6 and they ask me, can your tool help? And it can help. So if you're on Java 6, it's okay. Our tools can help you too. All right, so let's get started. So I want to level set with everyone. Where are we right now and what changed? So I start with a timeline. So back in 2011, we got Java 7, and it was out for a while. And 3 years later, we got Java 8 in 2014. And you just saw the normal 3-year mark between the two Java versions, and you usually did your migrations when Java 8 came out. And then Oracle announced that there's going to be a new release cadence, and we saw that with Java 9. So in September 2017, we saw that Java 9 came out, and there was a 6-month support for that version until the new version came out, which was Java 10. And as soon as that came out, Java 9 went out of support. Then we saw Java 11 come out, and with that one, that was declared a long-term supported release. That means that just like Java 8 and just like Java 7, if you go to Java 11, you can stay on Java 11 and get long-term support. What that means also is that if you're on a short-term supported Java version, then you need to update every 6 months. So Java 12 came out in March of 2019, and that went out of support when Java 13 came out last month. The reason I show this is because my focus is going from Java 8 to 11. I deal with developers that would rather not upgrade if they don't want to or they don't have to. And I understand that, so I usually tell them just focus on your migration from 8 to 11. And I'll share with you what I found with Java 11, but I'll also share with you what we found with Java 12 and 13, because I know some people want to be on that release cycle and want to keep using the new features that are coming out and all that good stuff. In the future, you'll see that Java 14 will be coming out, 15, 16, and then 17 will be designated the long-term supported release. And the reason I showed this one is because I saw a lot of developers online saying, all these Java versions coming out, and I'm still on 8, I can't keep up anymore. Well, it's a different release cycle, so don't compare yourself to where you were before to where you are now. If you want to keep doing what you've been doing for years, just focus on going from 8 to 11, and then 11 to 17 when it comes out. So my advice is run LTS on production, but do your continuous testing on the non-LTS versions. Because now that you have early access to those versions, why not just set up your CI/CD pipeline to continue testing with those new versions? That way, if there's any incompatibility, any issues, you're catching it early instead of waiting 3 years till 17 comes out. New features. So there's a lot of reasons why you should migrate, and there's a lot of cool new features. Lots of them are listed here. Some of my favorites is var and some of the helper methods that got added to collections. But I am not concerned with new features. I'm concerned with breaking features. So this is my only slide on new features. There's a lot of reasons to upgrade, and you can learn a lot about the new features, but we're going to focus on breaking changes today. Speaking of breaking changes, so modularity. If you're not familiar with modularity, Java wanted to be able to break up the JDK into different modules where your application can declare its dependency on the specific modules they're using. It's very useful if you're in a container environment, memory really matters, all that good stuff. Now the issue is it's pretty disruptive if you're coming from a Java 8 or earlier environment because they have no concept of modularity. Luckily, there is a kill switch and it is on by default. It's the illegal access property and is set to permit right now. And I wanted to show what you see when you print out the information because it says, well, it will be removed in future releases. So it's not going to be there forever, but you can take advantage of it right now while you're migrating. So usually what I tell people is keep the kill switch on, do your migration, take care of all the other stuff that got removed, and then you can turn on modularity. You can start breaking up your application if you want to, and so on and so forth. General migration concerns throughout is you'll see there are missing packages, missing classes, missing methods, and certain strategies that come with that is if something has been deprecated forever, like some of these APIs have been deprecated since 1.1 or 1.4, you should probably be replacing those. But if something is pretty strategic, you're still using them, they're like really important to your application, like the Java EE modules or Jakarta EE modules, you need to figure out what you're going to be doing about that, and I'll definitely touch on that in a bit. There's also always minor behavior changes that come with every Java update. That's why my team exists, because we want to do all those Java SE upgrades with minimal surprises. So we like to help people figure out if they're going to run into issues before they do. And of course, if you have application dependencies, you may need to upgrade your application dependencies to a Java 11 compatible version. So for example, for our tool, we had to upgrade to ASM 7.0 so that we can get Java 11 compatibility. All right, so I'm going to dive into details a little bit more. So I'll go through it a little bit fast, but there are tooling that I'm going to show you at the end that helps you with this. But let's get started with that. Okay, so first problem, and I think is the most disruptive issue, is that Java EE modules got removed from the JDK. Okay, what does that mean? That means that all of these modules, so activation, Corba, transaction, binding, WS, and annotation got removed. All right, what does that mean? If you're using any classes in these packages, you're no longer able to access them from the JDK. For us, the most problematic one was JAX-B because we were using a lot of XML to Java object libraries, and we were expecting it to be in the JDK, and it just broke once we switched to Java 11. All right, so what's the solution for this one? You have two solutions. You either package those libraries inside your application, or you rely on your application server to provide them. So in OpenLiberty, what we ended up doing is we ended up providing those packages when you switch to Java 11. That way, it's the least disruptive route. So all you'll need to do is just update your server.xml to include those packages, and they're just provided. If you're not using an app server that can provide those libraries, then you'll need to update your builds so that you can pull in those packages. More classes that got removed. So we have some security classes that got removed here, and those were deprecated since 1.4. So in your environment, you might have seen this squiggly line with a warning on it, and you just ignored it and ignored it. And then you switch to Java 11, and now it's thread. That means you really need to do something about it. For this one, if you're using any of the Solaris classes that got removed, you simply just replace them with the Unix equivalent of that. So a lot of these start with Solaris, you replace them with Unix, and there's a lot of documentation about the things that got deprecated and Oracle always tells you what the replacements should be. Also, a lot of the AWT peer APIs got removed. So this is a common call that I found. You're calling a method that's returning an object of AWT peer package type. So what's going to happen is you're going to switch to Java 11. The return class is no longer there, so it's going to give you a red squiggly line. You just need to replace it with is displayable. You'll get the same functionality you were trying to do before. Some DOM classes got removed, and the codec JPEG package got removed as well. So if you're using that, use Java image IO. The internal binding classes got removed. If you really, really want to use them, you can remove the internal off of the package and package up the JAXB packages in your application. But of course, Oracle always tells you shouldn't be reusing internal APIs. Oh. All right. So methods that got removed. So we talked about classes, talked about packages. There were other methods that got removed. So in Security Manager, there was a lot of check access methods that got removed. So again, in your IDE, you would have seen a warning. All of a sudden, you can't call that method anymore. You call check permission instead. So any of those methods, if you're using any of them, you can substitute it with check permission. In the threat class, we saw that destroy got removed and the stop with argument got removed. If you're using stop with no argument, that got deprecated, so suspicious. It's probably going to be removed soon. And then in the runtime class, we got the get localized input and get localized output streams got removed, and the run finalizer zone exit method got removed from runtime and from system. I like to show this bug because it kind of gives you the spirit of the changes that came with Java. Finalizers are inherently problematic, and their use can lead to performance issues, deadlocks, hangs, and other problematic behavior. So there's a lot of things about how you're cleaning up your resources in your application that Java wanted to kind of discourage, and you should use kind of better methodologies when you're doing this. So use a variable if you're trying to control a thread instead of doing, calling stop or finalize, and so on and so forth. There's also the change listeners got removed from log manager. You can use the global log manager object and use the read configuration method instead. And for unpacker and packer methods, the change listener got removed. You can pull the progress objects instead. All right, so general technology removers that got removed, that went away. Java Web Start. So if you're using Java Web Start, this might be problematic for you. If you're on a desktop application, you can use JLink. But I know the Adopt OpenJDK community is trying to figure out what else they can provide help with. So definitely check that out and see what they can do for you. Java FX became its own separate product. So it's no longer in the JDK, but now it's its own separate product. So you just pull it out from the website or wherever you get your dependencies from. Oh, went the wrong way. All right, this way. Other removals. So a lot of the internal APIs got removed. So you no longer can access base64 encoder and decoder, for example. Add JDK exported got removed. You're probably not familiar with this annotation. It was around for a little bit and then went away. You can use the module system now. And NetDoc protocol handler got removed. So now you get the malform exception, URL exception if you call this. Some behavior changes. So for get annotation send methods, you're just getting a different exception when you have error scenarios. And for those cases, I feel like a lot of developers are not going to be impacted. But maybe if your catch is specific to the exception that you're throwing, you might be impacted. So this is a little bit not as likely to hit you. And there's more. There's a compatibility guide pages and pages and pages of changes, but I highlighted the ones that I think are the most problematic and the most likely to hit your application. All right, so I said go to Java 11, but I also wanted to cover 12 and 13. So in 12, we saw that a lot of the finalized methods got removed. So in zip file, file input stream, file output stream, and so on and so forth. If you're using any of this, try with resources to clean up your resources, because it's a really nice, concise way to define your resources, and as soon as that try block is done executing, then your resources are already cleaned up, and it looks really nice when you're actually writing code. Security warning class got removed, and there were some behavior changes, like the user time zone system property now can return null when it used to return empty. So just be on the lookout for that, and load from XML is returning a different exception. And then I included a link to the migration guide here as well. 13 is a very small list. It was the trace instructions method got removed and a trace method calls, and the AWT toolkit system property got removed as well. And I included a link here. All right, so I talked about what changed. So what are you supposed to do? Are you supposed to look for all these calls in your methods and in your applications and see what hits and what doesn't? No, that's why our team did all this research, so you don't have to do the same thing. So I wanted to cover some of the tooling we have and show it off. And I'm really excited about this one because it's an Eclipse plugin, and we're at the EclipseCon, so that's definitely awesome. So what this Eclipse plugin does is it scans your application source code, and it tells you if there are any migration issues in there. It's available on Marketplace, so you can definitely search for it and find it over there. And it's also available on our download site. If you're using Oxygen or higher, hopefully you are, then you're going to see that available for you. So there's different scenarios that you can go from. So if you're still on 6, you can go to 11. It'll be a big jump, but if you're an 8, you can choose 11. You can choose 12. We still haven't done 13 quite yet, just because it came out and we're on a quarterly release cycle, but hopefully that'll be coming soon. And we do have multi-language support. So if you want to see the help files in German or French or so on and so forth, that's available for you within Eclipse. All right, so favorite part is the demo. So let's exit out of here and switch to Eclipse, if it happens. All right. All right, can people read? Is it good? Yes? No? All right, I'm seeing nodding, so that's great. Okay, so I want to start with the download website. So here is where you can get the Eclipse plugin. You can, of course, get it from Marketplace just like usual, but you can also use this button and drag and drop it in an Eclipse IDE if you're familiar with an Eclipse plugins. And there's a bunch of documentation down here and videos and so on and so forth. So if you want to learn anything more about it that I haven't covered here, the resources at the bottom here are really helpful for that. Okay, so let's take a look at what it does. So I have my Eclipse IDE here. I have my project imported. So I have a really simple My application, and it has a warning because I have something in there that's deprecated. What happens is, once you install the plugin, you click the Run menu, and this new analysis button is going to be available for you. Once you click it, you're going to need to create a new configuration and tell the scanner what to look for. So let's expand that a little bit more. And name it something meaningful. So I'm going from Java 8 to Java 11. And then you choose which project that you want to scan. So I want to scan my application. Then I switch over and I choose a rule set. In this case, I'm choosing the WebSphere application server version migration. If you're not using WebSphere, it's not a big deal. You just need to change it so that Liberty, you're coming from Liberty, going to Liberty. That way, it's just not going to select any rule set that has to do with app servers. The main thing you're interested in is the source Java version. So I'm coming from either Oracle Java 8 or IBM Java 8, or all of these are options for you. So check those out and see what applies to you. So I'm going to choose Oracle Java 8, and then I'm going to look at my options, have 11 or 12. I'm going to choose 11, and I'm going to click OK. Once I click OK, what's going to happen in the background is it's going to select the relevant rule set. So let me just show you what that looks like. So look, check this out. So we have all these rules, but the ones that are relevant to what you chose are the 11 compatibility impacts. So this is going to give you a whole list of all the things that we're looking for. And if you're curious about anything, like remove JDK exported annotation, you click on the question mark, and it comes up with a help. And then if you click detailed help, you'll get more information about what this change is. So all the solutions I was saying, really fast, really fast, really fast, well, if you actually have that problem in your application, then you can read all about it and look at the resources and only read about the things that impact your application. And if you started Eclipse in German, then you'll get this text in German. So I'm good. I don't need to know any more about the rules. I click Analyze. It's going to go off and analyze it. It'll depend on how big your application is. It can take several seconds. And it's launching. The file review is usually empty. And let's see. OK, so it got done. And let's take a look at what got produced. OK, do not use APIs from the Sun package. So you might look at that and wonder, OK, what does that mean? So what you want to do is you want to open up your help view so that you can learn more about those rules right within Eclipse. So it looks like I'm using a Sun API that is no longer there. But I want to see where exactly in my application am I doing this. So I double click on here. And it shows me in the code where I'm using it. So I'm using base64 encoder. I check out the help, and it's telling me, OK, what should I replace it with? Java util base64. And that's what I need to replace it with. So you rewrite your application, you replace it, rebuild, and then run on Java 11. So that's one of the many issues that it found. It also found the remove security method. So it looks like I'm using get in check, and it was deprecated. And then once I switch to Java 11, I know it's going to go away. So we want to remove that and replace it with check permission like we talked about. I tell you to run GDubs, and I'll talk about GDubs in a bit. And I also tell you about missing JAX-B API. So this is what shows up if you have any Java EE modules that went away. And it's telling you you need to either package up those dependencies in your application or rely on your application server to provide them. So that's it for the source scanner. And I wanted to also highlight the other tool that we have. Talk about it for just a little bit, which is the application binary scanner tool. So this tool is available for download on this website, and it's basically just a command line tool. It's a jar that you install and you run with Java 6 or beyond. It used to be Java 7 or beyond, and then we got a special request to get it working in Java 6, of course. So we made that happen. And what it does is, instead of scanning your source code, it's going to scan your binary code, so your binary files. In this case, if you don't have access to your source code, or maybe you're not using Eclipse or anything like that, this tool is also pretty helpful. It's looking for the same things that the Eclipse plugin is looking for, except it's looking at your binaries. So that's where ASM came in, if anyone's familiar with ASM here. It accepts EAR and WAR files. And if you're using jar files, you use the -- analyze Java SE option. I'll show that in a bit. And it produces an HTML report. After it scans your application, it'll tell you, OK, here's what I found. And it's going to be in HTML format. And here's a link to the documentation. And I'll post this slides after I'm done with the presentation. All right, let's demo it up. So you would download the binary scanner from this website. And once you download it, it's just going to download this jar. All you'll need to do is install the jar. So we're going to run Let's put this in a strategic position. All right. Java-jar binary app scanner installer.jar. And it's going to give you some licensing. I read all of it, so I'm going to skip. And then at the very bottom, it'll tell you, do you agree or disagree? You can disagree and move out, or you can agree and proceed. And then it'll ask you, okay, where do you want to install these files? And I'm just going to take the default. So what it's going to do is it's going to install the jar in a WAMT directory. And that's it. That's just all it takes to install the jar. It's pretty fast and simple. So here are my apps. I have a jar file and a war file, and I want to scan it for migration issues. So what I'm going to do is I'm going to tell the binary scanner where to find the application. So java-jar binary app scanner. I'm going to tell it, okay, I want to scan this application. Let's do my application.jar. So my application.jar. So you just told it what to scan. You want to tell it to analyze Java ECE issues. The reason why this is important is because we also scan for Java EE issues. We scan for traditional to Liberty issues. So you really want to tell it what to look for. And in your case, maybe you're just looking at 8 to 11 and nothing else. That's all you're interested in. So -- analyze Java ECE. And then you're going to tell me where you're coming from. So the available values is IBM 6, 7, 8, or Oracle 6, 7, 8, 9. I don't know. I don't think we removed 9 and 10. We just accept 11 because we didn't want to keep adding more values in here. So I'm going to say I'm coming from Oracle 8. Target Java is Java 11 or Java 12. I'm going to do Java 11 for now, and that's it. You've told it where to find the app. We've told it where you're coming from or where you're going to. Just really quick before we switch to the report, if you look and see what messages got printed out, we, by default, exclude any third-party APIs because you can't do anything about it. We just want you to scan your own application and change your own application. Now, if your company uses any of these packages for some reason, then you might want to review that and override it with included packages and exclude packages. So we did the scan. Here's the report. How it's coming up with the same issues that the source scanner came up with. It's going to tell you where it's coming from, where you're going to, scan options, and it'll tell you what the problem is. So you'll have 3 categories: severe, warning, informational. And if you go to severe, you'll see the same problem that I highlighted in the Eclipse plugin. So it's pretty much the same thing, but in a binary scanning form. All right. So that's the binary scanner. All right, so what's GDubs? So if you're not familiar with GDubs, GDubs is a tool that's shipped in the JDK. There's a bunch of options that come with JDubs, but the most relevant to people that are migrating is the -JDK internals option, and it accepts .jar, class files, and directories. So it doesn't accept .ear or war files. We will recommend that you run JDubs if you have any internal APIs in your application. The reason we did that is because when I scanned my application using JDubs, I couldn't find certain things that the binary scanner would have found, like removed methods or Java EE modules that were removed. So I felt like having something extra and then pointing to JDubs when appropriate would be more beneficial to developers. It's very version dependent. If you're coming from Java 8, don't run the JDubs that's in Java 8. Run it in your target. So if you're going to Java 11, run the JDubs in Java 11. And if you're going to Java 13, same. Run the JDubs in Java 13 because it knows about its own versioning information. All right. Talked. What should you do after the session? If you have any Java 8 application, if you're running in Eclipse IDE, download the plugin and run it. See what it comes up with, what issues it found. If you're not running in Eclipse or you want to just scan your binary files, then run the binary scanner. Run it against your tools, review the reports that it comes up with, and after resolving all of it, try running it with Java 11. And very optionally, I would love to know if the tool found what you had issues with when you go to Java 11 or not. Because that's how we keep improving the tool, is we have a user come in and say, I just went to Java 11 and it didn't find this issue. Why isn't it there? And we just keep adding rules as people report certain problems. So go ahead and do that. My Twitter handle is right here. I'd love to hear any feedback on that. And if you're looking for a free Java 11 build, check out Adopt OpenJDK. That's where I got my Java 11. I use OpenJDK 11 on OpenJ9, and I include a link here for you to check it out. References are resources. So if you want written instructions of what I just went through for the binary scanner, here's a link. If you want a video of how to scan your applications in Eclipse, here's a link, and there's a lot of other resources that I just wanted to include here in case you're looking through the slides and curious to know more information about any of these topics. And that's it. Any questions?